Okay. We're recording. Okay. So, Pat, when you're ready.
I am just finishing up a program change. Give me 10 seconds here.
So that means it may not work now due to that fact.
No, it was working just before I changed it back.
Ooh, big words, big words.
It works, it works. So I've been working on time of flight sensors. VL53L1X, I
Mm-hmm.
believe, is the one I've been using.
Yep, that's a good one, or that's the best they make, I think.
Yeah, so it's a Chinese version. Okay, I've got a reading on it as well, so that's good. It's a Chinese version of the sensor. Um, Basically, I'll share my screen, possibly. So can everybody see my screen?
Yep.
And, okay, so that's not the exact sensor I bought. It's basically it's a version of it. It
Mm-hmm.
comes with a little lens cap.
Mm-hmm.
And so I put that on my robot using a little mount that I printed. So I 2D printed it, Murray, not 3. So I've got that mounted on the robot, and just to give you an indication, I don't know if everybody can see that, if it's too small or what, but I've got 3 ultrasonic sensors on it and 2 infrared sensors running on an Arduino Nano. And I will show a picture or a video of it, if that'll help. See if I can see what I'm actually pointing at.
So Pat, one of the things I use most for my 3D printer is printing mounts for robotic sensors.
Yeah, so that's what I did. And I don't know if you can see in the bottom corner, I've got the little the infrared sensor there. So I've got 2 of them facing 45 degrees out from the side. And the ultrasonic sensors are essentially aiming in front of the robot and essentially in front of the wheels to cover the width of the robot and farther out as it goes.
Pat, do you recall what the field of view of those sensors are?
The ultrasonics, I believe, are 15 degrees.
No, I meant the depth sensors.
The infrared sensors, I'm not sure if they're 15 degrees also. They're pretty wide, I believe.
Now that's 15 per side, right? So you get. No, what I'm saying is, the cone is actually 30 degrees, isn't it? Or is the cone 15 degrees?
Typical field of view is 27 degrees, so
Okay.
it's slightly under 13 degrees each side of center on the sensors.
Right. Okay.
About 13 and a half degrees each side of center.
Okay. Are they running continuously, or are you polling them?
I am running them. They're in continuous mode, but I am polling them, taking a reading out of them once every scan of the routine,
Mm-hmm.
and then I publish the data when I publish my ultrasonic sensors.
Okay. I was looking at. It said it looked like your thing was 45 milliseconds. Is that?
Yeah, so I'm at approximately 45 milliseconds
Mm-hmm.
for the whole routine.
Mm-hmm.
So
And
I
getting.
believe the ultrasonic sensors are 8 or 9 milliseconds. And I'm using an Adafruit I2C multiplexer with those sensors because I can't change the I2C address easily.
Mm-hmm. Mm-hmm. Yeah. So, what's your thoughts?
So far, it looks to be pretty good. I've had it up and down the hallway here next to the back office where I am. And I've been getting some readings. I was hoping to have the robot rolling today, but no, I don't have it rolling.
Okay. Cool.
Pat, when you say the ultrasonics are 8 or 9 milliseconds, I'm not sure I follow that.
No, the infrared sensors
Ah.
are about 8 or 9 milliseconds to get a reading.
So what? Okay, Pat. I thought they were a lot longer than that. That was one of the reasons why I dismissed them was because they in the mode you'd most likely want to use. They were like 39 milliseconds, but this one is 10. Maybe I was using the last generation.
It seems to me when I did the routine with just one sensor, so when I pulled the milliseconds prior to switching the port on the I2C multiplexer, so I grabbed the milliseconds, I changed the port, or the port out of the multiplexer, and pulled the sensor, got my reading, and grabbed the milliseconds. I thought I was at 8 or 9 milliseconds. Just for that. Now sending takes also longer once I get the serial send in there as well to the PC. And then the ultrasonics are considerably slower.
Yeah.
So I'm using a poll version. I'm using the new ping library in essentially interrupt mode. But I find it's still not very fast to go through all the sensors.
Doug, also, you say 39 milliseconds. Let's call it 33 1/3. For an ultrasonic sensor that's dealing with the speed of sound, basically you have to go there and back. So 33 milliseconds is something that's 16 milliseconds away. And a good rule of thumb is sounds about 1,000 feet per second, so about a foot per millisecond. So that means the furthest you could see at 32 milliseconds is 16 feet, which seems about right for those little sensors.
Yeah, but they don't see that far. They're not like yours.
I've got them set right now to 200 centimeters, which is around 6.5 feet.
So that would be about.
I think you can do that. You can do, I think, up to about 72
Yeah,
inches.
with the new ping library, you can say, ignore anything coming back after that.
So that would be about 12 or 13 inches.
Yeah.
Did I do that backwards?
You did that
12 or
backwards.
13 milliseconds.
Yeah,
And that's about what you're
sorry.
seeing, right?
Yeah, so I'm at 200 centimeters, which is about 200 centimeters is about 6.5 feet.
So at about a foot per second, that's about, there and back, right? You have to go to the target and come back, so there's a multiplier in there.
Yeah.
So if it's 6.5 feet away, you have to actually travel 13 feet,
I have to travel double the distance.
which would be about
So
13 milliseconds, about.
at sea level at 1,100 feet per second or so, which gives me whatever 550 feet per second.
Are you at sea level there, Pat?
No, I'm 608 feet or so above.
Okay, close enough. We're about 800 feet, I think, here in Denver.
So yeah, so I'm not too worried about the math as long as I get something back consistent is what I'm looking at.
Well, I do the same thing. I throw away detections that are further than some arbitrarily induced amount.
Yeah, so the one I said I was just quickly redoing my code because I made a change and it wasn't working. I made a change to say that if my distance reading is greater than my maximum reading for my infrared sensors, make my reading 0. So come back saying essentially, hey, you didn't get anything. And it wasn't working. They're always coming back at 0 when I put that in. So I'll have to see what's wrong with my code.
Yeah. Yeah, it says it goes up to 50 hertz. Yeah, that's nicer than the ones I had.
Yeah, so
well, I
for
guess you have to.
simplicity's sake, because I use the same nano as my ultrasonic sensors, Arduino Nano. That's why I left it there and I did my reading once per. As quick as I can sample my ultrasonics is when I do my send.
Well, that's cool. When I did it, I was using the previous generation of these, Pat, and I ran into the same trouble with not being able to not be able to easily change the address per sensor. You can change the addresses of the sensors. They are changeable, but it's just kind of you have to stop the sensor, change it, start the next one. Yeah.
I tried for a month to put 2 sensors on the I2C line and basically ground, I forget what's the pin, on the sensor.
Yeah.
To basically say, hey, okay, you're not active, go to the other guy. So you take it and you change the address, and then you do the second sensor, or you can read the second sensor. And I had 0 luck with it. I tried and tried, and so finally I bought a little that group board from Adafruit.
Mm-hmm.
They're cheap. They're $10.
Yeah.
Even on eBay and on Amazon in Canada, they were $10. So.
Wow.
And how does that work exactly?
Basically, the board is at address 70. The board is at address 70 on the I2C bus. So you switch your wire interface to address 70, and then you give it the port number on the board that you want to talk to. So it's port 0 or port 1 or port 2 or port 7. Up to 0 to 7, there's 8 ports on it. And so you give it a port number, 1, 2, 3, and then the next communication you send through goes to that port directly. So
so that allows you to effectively use the same I2C address for all the devices.
Yeah, they're at hex 29, which is 41 decimal, I think, the I2C addresses on both of them. And I use, without changing their address, I'm communicating with both of them.
Gotcha.
Yeah. That's cool.
Yeah, so it was a neat little experiment. My next one is to get one of these things going on the robot, so I can get a little bit of feedback when it's running down the hallway.
Yeah, well, you might want to talk to Carl. He's, I think, worked that all out. He might be able to give you some code or some hints on how to go about that when he joins the meeting sometime. But I mean, I think he's already done some pretty crazy things with those.
I haven't plugged it in yet, but it'll be one of my next tests. Mm-hmm. And I think it might just go off of that nano board as well, and just use it to send out a couple different LEDs.
Mm-hmm. Yeah. I did notice when I was using the strip, in my Robo Columbus rover, I noticed that you might want to watch the bus because it can get they can add a lot of noise to the bus, those NeoPixels. So I'm just saying.
To which bus are you talking about?
The whole everything. I'm just saying. I guess power bus would be the way to say it. I'm just saying, watch it, and you might see a little spiky poos around on it. I'm trying to think of what I was looking at.
Because they're going to be powered not off the Arduino power supply, it is essentially off of the same regulator that the Arduino and the Raspberry Pi is plugged on.
Yeah. Well, I'm just saying, just take a look. Just be aware that they can add noise.
Okay.
Because they're changing at a frequency that's, I want to say it's 400 hertz or something. I don't know. I can't remember. Whatever their timing is. There's you've got basically a clock type thing going on, and it can interfere.
Yeah. So in my program, I've asked for. I'm just gonna go find out here to make sure. So brightness, updates per second. I've set it to 5.
Okay. Mm-hmm.
So basically, I didn't want it to be constantly trying to write to this thing. There's only 32 LEDs on it.
Mm. Yep.
So I
Okay, it's coming back to me now. Where I noticed it on my rover was that it was translating onto my RC bus. Otherwise, the servo bus.
Yep.
That's where I was seeing the spikes. Was on the servo bus. Otherwise, that's where you go from 5 to 5 to 15 milliseconds, and then you're off for a period, and then you come back up. I was seeing noise on that. That's what I remember seeing noise on. And I corrected it by putting a very small capacitor on those particular channels that I was seeing the problem on.
Okay, that's interesting. So you were seeing noise essentially through the would be essentially through the 5 volts on the Arduino.
Yeah, probably. So anyway, just it works, and Carl's been using it quite a bit, and so it's not that big a deal. I'm just saying just be aware of it.
Were you powering the LEDs through the Arduino?
No, you can't. I think you can, if I want to say, you can do 5 of the LEDs through a Nano or Uno or a Mega, and that takes the whole power budget.
Yeah.
So you can't, otherwise, like in that thing where you have 32, you're going to have to independently power it.
That's the plan, is to have it powered off the 5-volt linear regulator and not through the Arduino or the
Yeah.
Raspberry Pi.
You can't do it through those guys. Like I said, I think the strip that I have from it's an Adafruit strip. I think it's the absolute max, or even one over the amount that you can do off of and it's just a little short strip.
A question, Pat. These sensors have if I understood the data sheet correctly, a 16 by 16 array of spads, and you select what size region of interest you want out of the available spads. What did you do that, and what did you choose?
No, from my understanding, these ones are not the new ones that is it Texas Instruments or STM put out, ST Electronics.
Yep.
That's the next version up, I believe, the next generation that has up to a 16 by 16 or an 8 by 8 ROI. These don't.
I see.
They have a single point.
I see. And David, you ordered the new generation ones, right?
David who?
David Anderson? No audio.
How about now?
Yep.
Yeah.
Okay, I'm sorry I missed the question.
You ordered one of these ranging sensors, but I thought you ordered, or at least you said you were going to. Don't know if you did. But I looked up the part number after you said it. Yeah. Okay, that's the 53L1. So that's the 16 by 16 array one.
Yeah, so which ones do you have, Pat? I thought you said you had a 53.
I have a 53L1 as well, but as far as I know, those aren't the 16 by 16 array.
I don't think that's
these
correct.
have been out for a few years.
I'm looking at the data sheet for the BL53L1X, and it says it's got a 16 by 16 array, and you can select an ROI between 4x4 and 16 by 16.
Now, if it makes any difference, this one doesn't say X. That's backwards, isn't it?
Okay.
Okay, there's a 53L0X, and then there's a 53L1X. Now,
Doug did a great talk on this a few months ago. And went through all the different boards.
Oh, that was longer than that was the earlier generation ones. Yeah.
I'm just trying to find an email I have here on probably in trash.
So you're saying a few months ago was like 2 years ago?
Something like that. Yeah. Give or take a month.
Yeah, SparkFun makes a VL53L5CX, which is it's the ST one that has the 16 by 16 pad in it that you can address, the individual ones. You can do 16 by 16 or 4 by 4, and they've done a processing app, I guess you could say, that will show you all of the array, all of the sensors in like a 3D rendering of what the sensors would be. I don't know if anybody's seen that or not.
Yeah, I was just trying to find where I put it, but I thought I deleted it. I can't find it in my cache.
Yeah, the 53L1X definitely has the 16 by 16 SPAD.
Okay.
So the real,
I'll show again.
but it could be one of those things that if you don't do anything, you get a default size and that's it.
So that's the one I have, and there's the sensor on it.
It says it's the VL53L1X.
It does, but it mentions nothing about, well, it does say programmable region of interest.
Yeah, I think that's what that is.
Yep.
Well, there you go. I'll have to do some reading on it, see if I can narrow my field of vision.
No, actually.
Yeah, because it seemed to me that you would be, with as wide a cone as it had, 27 degrees, that if you did the full 64 by 64, that you'd maybe be picking up the ground on some of the beams that were, I assume, that were pointing downwards.
Yes, so I've done a few on the ground, and I did pick up the wall. So the distances it was reporting back at 16, 18 inches was the wall, but I haven't tried to go farther to see, okay, well, does it see infinity on one of them?
Yeah, that's the same chip as on the SparkFun one, and you can either program it for 16 or 64 zones. And I haven't got mine in the mail yet. It takes a long time now. But the idea would be to basically drop the whole lower half of the thing off. You don't want to catch, depending on how you aim it, of course. I'm going to drop the whole bottom half of my sensor off because I'm not interested in that, and use it for kind of horizon upward.
Yeah, so there is where I've set it, and I haven't gone into the program to see. I put a distance of medium in the settings for that sensor.
Yeah, as I understood the data sheet, the distance settings that you could put, that they had, you had long range, medium range, and short range, if I remember correctly, and those had to do with how noisy the sensor output was in the presence of ambient light. So it was rated to, you would have to set long range to get the 4 meters range, but then it wouldn't work properly if there was ambient light. And conversely, if you were outside in the sun, I seem to recall you had to set the short range, which gave it a range of maybe 0.7 meters or so, if I'm remembering the data sheet correctly.
Okay. So the one Ray is showing right now is the one I believe that was the array.
Yeah, this is the one with the array, and that's the processing app that, somebody's waving their hand in front of it. You can sense gestures if you want.
So I was kind of curious about that, Pat, and it sounds like you haven't dug in far enough yet to really understand the 64 SPADs, but I was wondering, when you were describing the output and what you're printing for an output, you're printing a single digit, a single distance, and Yet Ray just showed 256 distances coming back. So
Yeah,
you know,
but Ray, I believe, is showing it. Is that a different sensor, Ray?
No, it's the one, the VL53L5CX. I put it in the
Yeah,
chat
that's
and
the 5CX, not the L1X.
correct. I think they've always had, a number of SPADs. I don't think they let it be known how to use them, and I think it took a while for some reason for that to be released. I don't know if there was an agreement with maybe one of their biggest customers not to release that or something, but I remember them saying that they had, a large number of SPAs that you could access, but never saw anybody do it. And apparently ST was pretty tight-lipped about, how to do that. So this was the first one I've seen where you can access, or access the individual SPAD inside.
Yeah, I'm just on ST's site right now looking at the chip, and it definitely talks about a region of interest, but
Yeah.
I don't believe I've seen that in the program. And
That's what I know of, yeah.
Pat, have you looked into the SparkFun library? They have a link on their website to what they're calling an Arduino library that supports the zones of interest for their board. But I'm assuming it's the same chip. It should probably be the same library.
yeah, I just never dug that deep into the library to see.
Yeah, I'm kind of thinking I might have to try to port that to Python, so I've been looking into it myself.
There's examples with it on Python out there. I know that.
Really? Oh, if you could put that into the mailing list or something, because I haven't been able to find anything in Python so far.
Oh, I was looking for one today, and I found it. I said, oh, damn, it's in Python.
Oh, well, that's what I want, so that'd be great.
I'll go through my history and see if I can find it.
Well, thanks. You can put it in the mailing list. I think other people would find that helpful too.
Okay.
And I'll put into the mailing list the link to the SparkFun one, because that's an Arduino library that other people might use as well.
Yeah, I'm using, I believe it's the Polulu library, and I'm not seeing a region of interest in it. Oh, yeah. There are.
Two things. This is the data sheet where they talk about the distance mode, short, medium, and long, and the maximum distance it can sense in the dark in centimeters or under strong ambient light in centimeters. So,
Paul, we don't see anything.
You're presenting the wrong screen, Paul.
So I'm in the Pololu library, and there is definitely a set ROI size, width by height.
It does occur to me though that I'm looking at the SparkFun one, and I think it's a different chip. Are you using the VL53L5CX or the L1?
I'm using the L1, and I've got the L1 library.
Yeah, I purchased the L5, which might be different, but they both say they have a zone of interest. So I don't know. But I'll put the link to the Arduino library into the mailing list.
is this showing through now key parameters?
No, it's showing Oak D light.
Oh. Okay. Oh. Okay, let me just see if I can fix that by talking.
Speaking of the OP light, did anybody else get their notice that they're ready to send them out?
I did.
Yep, me too.
Thanks for the heads up on the mailing list, guys. Whoever said the email came in, because I used that.
Paul, you still looking for that screen?
Yeah.
I'm just trying to pull pull up what I grabbed out of the library as well.
So you're using, Pat, you're using the Adafruit library?
I'm using the Pololu library
Okay.
for my sensor.
Okay. I did notice that there are two data sheets for what it's worth. There's a data sheet for the LV53L1, and there's a data sheet for the LV53L1CX OFY. So there must be either packaging or some difference between the two versions.
Okay, this should be it.
Key parameters?
Key parameters, distance mode. So
Distance
here's
mode.
the three distance modes, short, medium, and long, and the maximum distance. So this has to do with noise. Basically, if you set short, it's more immune to ambient light, but the maximum ranging distance is shorter. And so in the dark, these are the maximum ranges it can measure based on short, medium, and long. Under strong ambient light, these are the maximum distances under short, medium, and long. And so you can see if you set it to long, you get a long distance in dark, but you get a very short distance that's measurable under strong ambient light. Versus if you set it to short, you get a shorter distance in dark, but a longer distance in strong ambient light.
Otherwise, that's where it should be run probably.
Right, and then this is the shows the sensor with the 16 by 16 spads with a 4x4 center 4x4 matrix set in the middle. So maybe there's some default that they ship it with.
Well,
Gives you
I guess the question I would have is, what constitutes short, medium, and long? Is it the SPAD size?
No, it's a setting that you set in the parameters for the device.
Okay, so
I pasted part of the library on in the text in the chat, and so you can set an ROI, width and height, and you can set the center position of your SPAD.
Right.
do you have any setting which is short, medium, and long? Didn't you say you had in your code you had something set to medium?
Yeah, so I set in my code, I have it set to medium right now. And
So if you can basically steer around a smaller spot in the sensor. Is that what you're saying?
yes,
So you could track things. Can you do that in real time, or is it just a setup thing?
that's a setup thing, I believe.
Well, I think I think what Ray was showing was a hand being waved over the sensor, and a program that's been written to show you the individual 64 pixels, for the lack of a better word, or 64 spads. He was showing a hand being waved over it, and so that you can imagine it can probably track a hand.
Yeah, so I don't believe that's the way this one works. I believe this one will return the shortest value out of all the SPADs.
Actually, for navigation, that's what you need.
Yes.
You just need to know what's closest.
It's just, like you say, I'd be curious as to if I put something that sticks up, let's say an inch on the floor, and I want to ignore it because I got 6-inch wheels and I'll run over the cat's tail. It's, so I want to make sure that I'm not picking that up.
Well, I guess you could just kind of model your cone, and you could see, some, even if you have it pointed straight ahead, if it's if the cone is represented by a rectangle and it's going out at 27 degrees, and eventually it's going to hit the floor somewhere out there. The question is,
That's the problem I had with my ultrasonics outside.
yeah, but I guess it depends on whether that's in your area of interest, distance of interest.
This is in some ways a classic problem of how you keep forward-looking sensors from seeing the floor. And on a lot of our robots, or I should personalize it and say my robots, the way you do that is you mount the sensor down low and you angle it up. So basically the bottom, even if it's spreading, the bottom spreading edge stays parallel with the floor. And that's the way you basically ignore. Hopefully you can choose, as you say. I'd like to see things that are at least 1.5 inches tall, or 2 inches tall or something. I don't want to see anything any shorter than that because I can probably drive over it. And no, you can't drive over your cat's tail. It's impossible. It just flows away like liquid.
I don't have a cat. I thought about doing that with angling a sensor up. I thought about doing that with a camera. So using like a Raspberry Pi camera or something and aiming it up so that I would be, let's say, 1 inch above the floor.
Exactly.
At the lowest point in the camera's view. So basically I'd be seeing 1 inch off the floor all the way up to the ceiling.
That way you don't have to do image processing to identify and get rid of the floor.
Yeah, so I have tile and hardwood floor, and the hardwood floor has lines in it all over the place, you see, and the tile floor, well, hey, it's a pattern too, so. I haven't tried it yet, though. That was one of my ideas, to mount the camera as low as I can get it and have it looking up.
Just make sure you warn anyone with a Raspberry tilt on. Our robots are kind of short.
By the way, David, my cat does not have a tail, so there.
They're even harder to roll over.
Yeah, he rolled over it already.
I've had the sonar arrays on the indoor robot, but the outdoor is different. But on the indoor robot, they're both canted back. They actually turn away from each other and they're canted back. And those spread at about a 15-degree beam. And the way I have them adjusted is that they still hit the floor, but it's out at about around 27 feet. And I ignore everything that's more than, say, 25 feet anyway. So,
yeah, well, that's what I said. I'm doing with ultrasonics is 200 centimeters out, so 6.5 feet out. Inside, I'm not concerned with it.
In the outdoor robot, the sonars are actually mounted on a pivot driven by a servo controlled by the level axis of the IMU, so that they remain level as the robot fits up and down. Actually, that's not just a trinket. I actually had to do that. The problem it solved was if the robot is coming down a slope and say going down into a ditch and then starting up the slope on the other side, it will see the other side of that ditch as an obstacle. And so it'll turn and traverse until it gets on the other side, at which point it'll straighten back down. So
wouldn't it, when it's going uphill, do the same thing? See the ground directly in front of it?
Well, there's only a certain amount that it can tilt down. Basically, it can only tilt down a few degrees from level. So mostly what that does, so for example, if you go back and look at some of the older films of J-Bot, you can see when it goes off the curb that it does a little turn, because just for a moment, the sonar sees the ground. But with the new setup, it doesn't do that. Also, coming down a steep flight of stairs, it would see the landing at the bottom and turn around and go back up the steps. Couldn't get off the stairs. Whereas now, that's not a problem. But it's cool to watch it because, it's like a gazelle's head. It just stays level, no matter what.
I don't have that problem. It bounces about the second step, and then it bounces about the sixth step, and then it hits the concrete floor and smashes to bits. And then it doesn't turn around after that.
Yeah, David described this functionality a long time ago, and I have been confounded by that ever since because it feels like the whole front sensor on my robot is all these different, IR and different sensors. I've thought maybe I need to have that entire armature tilting up and down in order to be able to go off-road. So I've just decided I'm going to stay on flat surfaces.
Well, I was going to say, if you're indoors, it doesn't really matter. Well,
yeah, but it's for the
That's
Mars
hilarious, Steve, that you ran into that with your robot, because I ran into that on the army trucks, because we had this area where we go down into a little valley, a pretty sharp upturn at the valley, and the LiDAR would, just as you say, hit the road at the far end of the valley, and it would jam on the brakes, and then it would like start back up again as it like coasted through the bottom of the valley.
exactly the same. And of course, what JBot would do is that whichever sonar saw it first, it would turn away. And so what that actually effectively did was it would do a traverse until the navigation straightened it out. A traverse across a steep slope is not necessarily a bad thing. In some cases, look how smart it was. Paul, that was an excellent talk. I'm sorry I didn't get to see the whole thing. Maybe there's some way I can go back on it, but thank you so much. It's great to get a more concise view of all the things you've been through and inform us a little bit about what's out there. I must say, the idea of programming one of those great big monstrous military vehicles scares me to death.
Well, thank you for encouraging me to do it, David. And I did send you an email, which evidently you haven't seen yet. But if you send me a Google account name, then I'll enable you to view the video.
Thank you.
So, Paul, you never ran over a expensive car or anything accidentally with that thing?
Well, there were some exciting times. We had a plastic rear of a car intended to test the stopping range distance, and we set up on this track that went around the airfield at the Army ATAC, the Army Test Center, and it was the most amazing thing. They were testing whether it could stop quickly enough. So they loaded one of those PLSs up with 20 tons of concrete, and then they brought it around around the track, around the end of the airstrip. It was doing, I want to say 65. They worked the speed up incrementally, wow. But they got it up to 65, and you could hear the diesel roaring before you could see the truck come around the corner. And then it came approaching this car that was sitting in the middle of the path where it was programmed to go, and then it saw, the sensor saw the car and started applying the pneumatic brakes, and you heard this, and you saw like the wheels would sort of momentarily lock, and then the anti-slip would like release, and it was the darndest thing, and it stopped about maybe 6 feet before the back of the car.
Wow. Sounds like some kind of Jason Bourne movie or something.
To the question of did we hit anything, I never saw it happen, but apparently while the software was under development, they did actually hit the back of one of these plastic cars and launched it, and completely destroyed it, and launched it about 30 feet in front of the truck.
Yeah.
Wow.
Yeah.
That's one of those things. What could go wrong?
That was. I had more fun on that job than I should have been allowed to have.
Okay, hey, you finished, Pat? Pat.
I am done. I've spoken enough for tonight.
Okay. Kareem, how did the extendable robot do in its Saturday competition?
Horribly.
Do you?
Absolutely horribly.
Oh no!
As if you didn't all know that was going to happen.
Let's see. In one match, um, rookie failure, their driver station, which is the handheld device that the controllers plug into, that then talks to the robot, it died just because their battery wasn't fully charged. In another one, the robot's power switch connection fell apart right at the beginning of the match, and so the robot just sat there. Another one, they managed to actually flip the robot over, which we kind of saw as a pretty good likelihood, because there was no like control in the software to manage like the amount of momentum that was building up, and they still had a setting to basically when you set the motor power to 0, they would break, right? So it would wind up and it would stop, and then the whole thing flipped over. So they only had 5 matches, and I only saw one of them, and that was pretty sad also. Um, the whole thing was like pulling itself apart, right? The wiring, you expand it, and the wiring would all pull apart. Um, that's what's going to happen when you try to do the wiring between like 3 a.m. and 5 a.m. the night of the competition. Three of the kids pulled an all-nighter. So heroic efforts, but the robot just wasn't there. And you got to understand that none of the subsystems were tested from a software standpoint either. I mean, the thing was just flopping around like a dead crab, especially when it was like upside down. You know, it's like it was pretty sad. Um, the the only thing that came good that came out of the tournament that was good was they still qualified for the regional championship on awards. So you know their robot performance was horrible, but they managed to demonstrate that they had a very ambitious robot, and it's just not quite there yet. You know they're now at the stage. I think that effort of preparing for the tournament was a driver, and so they'll be close. Their second tournament will be coming up towards the end of January, but they're already qualified to the championship. So, but I'm hoping that they will take the opportunity to get the software all worked out and drivers practiced and all of that stuff, so that next time they'll have a decent performance.
So the robot build is a go.
The build is pretty much a go. They basically got it assembled. Again, the wiring has to be completely redone. Right?
Yeah.
It is difficult to get wiring done at the best of times, and when you've got an expanding robot that expands 3 times its length, you got to be really careful about some things. And they just didn't have the time to do it. But it's all stuff they've tackled in the past, and I'm sure that they'll get there. There's probably going to be rebuild, so or even redesign. The fact that it turned over was partly due to the design. It has a high center of mass, and so like over the last couple of days, they've been discussing, can they take the motors that are sitting right now on top of the wheels and put them inside the wheels, basically turn them into almost like hub motors. They're not real hub motors, they're still regular motors, but the wheels are big enough, they're 8-inch wheels. So they're talking about reprinting, like printing a custom hub or machining a custom hub and figuring out how to put the motor inside of it. And that will lower the center of mass dramatically. And it will also shave some height off at the top of the robot, because there's probably a good 2.5 inches or something like that is being allocated to the motor housing, and that would come down inside the wheels. So that would be an interesting thing, but that means that all of that machining that they did, all of the design of those metallic plates, the aluminum plates on the motor modules, that would have to be redone. And I guess they would probably do it in carbon fiber this time. They did manage to get their carbon fiber arm done, and so that was an interesting. Basically last week there were some splinters flying around. We did a pretty much good control over the carbon fiber machining. We had the vacuum on the entire time. it is not possible to completely finish the carbon fiber on the CNC. You know, you still have to sand down the edges and deburr the drill holes, um, and that's a manual hand finishing process, and they didn't get all of them. So one of our drivers managed to get a splinter in his finger, um, but and I picked up um, some itchiness, I guess. It wasn't as bad as I was expecting. You know, the horror stories are out there, but you know, it was less than what I've had just dealing with fiberglass in the past. But I think that's just because we had, you know, all of our we had vacuum to the outside. We put in a vortex stage on the vacuum and a brand new filter bag and put the whole thing outside. So it gets sucked out pretty well.
But you have that running your finger along an edge to see if it's smooth.
Yeah, you don't want to do that.
And, and it's the same thing with fiberglass. It's just as nasty. But
Yeah.
the problem with carbon fiber is you get one of those splinters in, and your body doesn't react to it like it would a normal foreign object. And
Well,
it
ours
does.
did all come back out. So,
Well, and they can form nasty stuff down in there.
yeah.
Ugh.
Well, we were pretty serious about it.
Sounds
Right?
like
We
you're doing it right. Yeah.
Yeah. But yeah, you're going to be exposed to it a little bit. There's no doubt about it. But that was our first foray into carbon fiber, and it went pretty well. Ended up being a little bit more flexible than we were expecting it to be, probably because of the amount of cutouts that we did to further lighten it. And so, you know, the arm might not be as rigid as it used to be. But we can't really know because the software was so messed up on control of it that it never got to the point where we could really test it properly. But you know, I think that they're going to get there, and they're still pretty happy about like going over the robots for the last 3-4 years. They sort of have this feeling that this is the one that is closest, has the most potential to actually perform well in the game. That's never been their biggest thing. It's more about the game sets the parameters, and well, let's see what we can do about that, right? It's more about exploring the envelope. But this time they think that with its ability to be a continuous accordion, it's actually going to be a strategic advantage. And once they actually get it working, they're hoping to be competitive on the scores.
Well, did you get a big round of applause?
Applause.
Yes, applause.
Applause. Well, yeah, you get applause. Everybody gets applause when they're announced as the winner of an award. So that's good. They get to go up and get their trophy and all of that jazz. My team erupted. So we were right on the border of advancement. They got the Innovate Award, which was basically because of the robot's crazy design, and that's the one that we always care about the most. But that award is not high enough up in the ranks to advance them. There were only 4 advancements at this tournament, and they alternate between robot game performance and awards. And they were like 1 award down from where their highest award was Inspire 3. They were 1 award down from the number of advancements. But it turns out that one of the teams above them had already advanced. So that spot opened up, and they were the last one to advance to regionals. And my team did erupt on that one. It's like that was loud. They were screaming in my ear. They were very happy to advance.
Cool.
It's okay to be fourth in a competition with 4 people.
They were 25th in a competition of 28 in the game performance.
It beats a participation trophy,
Yeah.
You don't want to get that.
Well, that's cool. Who wants to go next? Anybody?
I have a question, so I guess I'll throw it out there because I was surfing the Reddit and I hit something. I'm like, what is this? So let me share a screen.
Non-web exploration. Dealer timing.
So, so my question is, what is an ESC switch? So there's this 3D printed RC tank that has, amongst other things and components, it has that. In other words, they wire it eventually to the RC remote thing. So is it a voltage regulator that the Adria board can control? At least that's the way I read this.
Is it a MOSFET switch or is it a?
I'll go up and show you.
An
Because
ESC is normally an acronym for an electronic speed control,
Yeah.
such as
yeah,
a
sort of.
WN circuit.
Is it maybe just a non-off switch for the ESC?
Oh, you said Bush ESC, and I think it does more like 10 steps or type.
Yeah, that's just the motor controller for the
Yeah.
brush motor.
It's a electronic speed controller for a
Yeah.
brush motor,
Yeah,
and there's two of them. And some people call them switches when they're really, they have a range of power on.
yeah.
Right.
Not all ESCs have reverse.
Okay, because it talks
Yeah.
about power use, forward control, current peak type things. It really doesn't tell you much, other than the fact that.
It's like a version of an H bridge. That doesn't necessarily
Okay,
have
so that's what I
reverse.
was thinking. It was basically an East Bridge, sort of.
Yeah.
Ooh, this is something I know something about.
Yeah,
They the ESCs you can control them just like you would a servo, and use this like when I've used them on with the Arduino, I just use the same servo library that you would
Right.
for a servo, and 90 is stop, and 0 would be full reverse, and 180 would be full forward, and of course it varies in between, and he's just using each one to control each motor to have his track steering. That's what I tried to do that and use a V-tail splitter to control each speed control, and so I could get because the controller I have doesn't do mixing, so the V-tail controller would mix the throttle and the steering into forward and reverse for each track.
They're typically a lot cheaper than H bridges.
Yep.
Because they basically have more scale, but they're limited in options. Like they may not have the ability to brake on zero power or that kind of thing.
Oh yeah, definitely.
And they may not have may or may not have reverse.
Yeah, that's what ate my lunch at, or one of the things that ate my lunch at Robo Columbus was I had the wrong ESC. And you want to get one that has forward and reverse. If you're not careful, you'll get one that gets forward braked and reverse. And the forward braked and reverse gets real tricky when you're trying to go from forward to reverse. I could never get it to work, but the forward and reverse, which is for rock crawlers, work great.
Yeah, because in the RC car world, for racing, you're not allowed to have reverse.
Yeah.
So a lot of them don't have reverse, and you got to look for one that does.
Yep.
And if you're getting one that's built for aircraft, it's not going to have reverse typically.
Yep.
Yeah, I guess that would probably be a bad thing, huh?
Might cause some. You might flip it over in the middle, right? Fuck. Like a dead crab, huh?
But on real aircraft, you can go reverse, can't they?
What?
On real aircraft, well, they don't actually make the engine go reverse. They actually change the cant of the propeller, don't they?
That is correct.
Yeah. They don't actually make the engine go reverse. That would be very difficult.
Mhm.
I thought they did on jets, don't they?
Some of the RC electric planes that can land real slow, you can reverse the engine to slow the thing down. With electric engine.
Now, Ray, on jets, they usually have a
Right.
plate that comes up and pushes the jet blast forward.
Right.
Oh, really? I haven't seen that though. I mean, they used to do that. I know a lot of some of the American planes, American Airlines planes used to do that. But
I don't think there's any way you can drive a jet backwards.
No, because the
Never
actual
remember.
yeah,
There's
because
no
the
way.
actual
the turbine blades are
lines
fixed.
are one direction.
The turbine blades would be pointed the wrong way.
Yeah. Yep.
You could potentially, on a turbojet, you could potentially reverse the drivetrain coming out of it.
But
not
it's
the
so
jet
much
itself.
easier.
But that would be that would be a challenge right there.
I think it's easier just to reverse the pitch of the prop.
Yeah.
So, the code they have for this was pretty nice too. I don't know if y'all want to see the code behind this. In other words, it looks like it was reasonably documented well. So, I can show you the code if you want to see that. But I guess I'll do that.
You don't have to do a Google search on that. I wonder what most planes use these days. Yeah.
Probably a pitch if it's a propeller.
Most airlines don't have propeller planes anymore.
Well, no, they do.
They do, the small ones, real
Right.
small ones, the puddle jumpers.
Military has a lot.
So here's the code. So where were you saying you think he might put that? See, because there's retails.
That's where it is, right in there. One of those is the ECN. Two, well, I guess two of them are for his.
It looks like, guess what? He has one speed or two speeds. Turn left, turn right at night.
No, I think that's how you read the channel. That's probably the maximum and the minimum and maybe the neutral.
Okay, so you don't think it has like different speeds?
Well, yeah, you do. You set the speed, but there's a range of speeds that you can have,
Right.
and there's a default speed.
The only thing I see is this if statement where it says if it's greater than 9 or less than 9, S value, maybe that's where there's subtracting the speed. Okay. Okay. Okay, so unless it's right in there where you get the speed range. But anyway, he has code out there too, so as I said, it looks like, the code, the documentation, all of it look pretty good.
Well, let's see a finished tank. That's kind of curious.
Oh, now we close that window down? Forgot. No, I didn't. Good. Okay, I'll swap back to the other window. Doesn't have a video. Go to the top. Well, that's how it looks when it's all put together.
So it doesn't look like he 3D printed his tracks. He must have had a.
No, that was bought. Yeah.
Yeah.
It wasn't actually a bad price. Yeah. So yeah, you got it on eBay, or it's like most things.
Okay.
About $15. So yeah, for 4 pieces.
Okay.
So yeah, it looks like not a bad overall price little robot. And relatively straightforward. See, there's the part.
Mm-hmm.
It looks like it has a reasonable front pitch in the front, so it wouldn't get hit doing anything. And, you know, he has a pretty well layout in the center there. And as I said, reasonably documented, you know, as to all the parts, steps, stuff that he used.
Another possible frame if somebody wants to go there. Yeah.
So that's what I have for today.
Okay. Okay. Hey Ray, you got anything?
Mm-mm.
Okay. Hey Paul, you got anything new? I know you were doing.
No, but I just did want to look back, if you guys don't mind, to David's description of his sensors on a servo, and how when the robot is pointed down, he uses the pitch reading out of the IMU to tilt the sensors so they're horizontal. And so a consequence of that is, sure, it doesn't see the floor that's ahead of it, but it's also blind to anything. So if it was going down a slope, for example, the sensors would be looking horizontally, and it wouldn't see anything that was on the ground until it was much closer to it than normally if it was on flat ground.
That's a good point.
That's correct. So that if it was on flat ground and there was a little stub sticking up 3 or 4 inches, it would see it. But if it was actually going downhill, it wouldn't see it. And all I can do is report from experience that that phenomena is less common than the phenomena of it seeing the ground on the slope.
Which does it all the time.
Yeah, on the outdoor robot, if it bumps into things that it can't see, it handles that separately.
David, well, there may be a possible next generation thing. Otherwise, if you had other sensors picking up something, maybe that main sensor thing would go, tilt down or something.
I've stuck a couple of IR sensors on it. That would always be parallel to whatever surface it was driving on. But my experience is that IR sensors just really don't work very well out there. At least not the ones I was using. They get the sun blinds. And on the plus side, foliage reflects IR really well. So you can, for example, stay on a sidewalk that has grass on either side of it just by avoiding the IR reflection. You really see those well. But as I say, it really wasn't dependable enough for me to rely on.
Okay.
Maybe one of these depth sensors.
It's going to be real interesting when the OAKDs come out, the OAKD lights. See if that changes the whole ball of wax.
There's also a physical bumper on the front of that.
Yeah.
But Bob, you're correct. And on average, the robot runs on a level surface, on average. Depends on how big your average. On average, the Earth is flat. Right?
Only takes one.
Thanks for the explanation, David. That was the kind of clarification I was looking for.
Well, I'd like a clarification. Can I jump in and take some of Paul's time?
Sure. Paul can.
In your talk, you were talking about calculating the centroid of the robot. And for those of us who use a differential drive or at least zero turning radius, that's an easy number to come up with because it's basically the center of the robot between the drive wheels. But for a Ackerman type steered device, the center of the radius of turn is always outside of the base of the robot or the vehicle. And so let's see. Can I present?
Yeah. Sure.
Present now. Can you see that?
Mm-hmm.
Okay, this is from Wikipedia, right?
Mm-hmm.
So this is an Ackerman steering. And you can see that the two rear wheels are basically along the same radius. And so you think of the turning point as a point that's projected from the two rear wheels. If you then project radiuses to the two front wheels, it becomes obvious that they are turning on different radii, that the inner wheel, the one turning away from the car, is turning on a tighter radius than the outer wheel, the one turning toward the car. They're turning on two different circles. And hence the need for Ackerman steering. There's actually a kind of a cool animation here. Let me see if I can find it. Oh, this shows how you have to set that up. The whole reason that Ackerman steering, we use that term generally to mean any front wheel steered vehicle, but that's actually not true. You have to have, what makes it Ackerman steering is that the steering arms are not parallel, and they have this geometry. So that produces what you want, which is that the outward turning wheel needs to be a smaller radius than the inward. Yeah. Can you guys see this little animation here?
Yep.
Mm-hmm.
If not, you can just go to the Wikipedia Ackerman page. So you see how, because the two are driven and they're not in parallel, the one that's turning away from the car turns a small amount. The one that's turning toward the car turns a large amount. And if you arrange that in this geometry, then those two will be exactly on the radius of the radius of the circle that you need for those two. So okay, so in any case, the center of turning, unless you have zero turning radius, the center of turning is outside of the base. And so Paul was describing how the center of the vehicle was calculated as basically back between two of the back axles, I think. And I'm not sure exactly how that works unless you have a vehicle that has zero turning radius, unless you have a vehicle that can rotate in place.
Yeah. So you are referring to the point about which the vehicle turns. That's the Wikipedia picture that you just showed, and it's the point in the world frame about which the vehicle is considered to rotate when turning. But in the vehicle frame, the vehicle can be thought of as rotating within its own frame, irrespective of the world. And so that's the point. That's the what we call the vehicle origin, or the point about which the vehicle was considered to turn.
Well, Paul, would that just be the point between, in the previous image from Wikipedia, that's just the point between the two rear axles in that simple design?
Yes, that's as simple as it is for a two-axle vehicle. Where it got a bit messier was with the like the tractor units that had two rear axles and a front axle. In that case, the nav guy said that the vehicle should be considered to turn about the center point, a point that is on the center line of the vehicle and midway between the two rear axles.
Midway
Between the two rear axles. So the idea is the two rear axles, they're like a skid steer, really. And so you take the two, that was how we defined it.
At least one that you showed us, you said that the rearmost axle wheels steered. So that must make it even more complex.
Yes, and so on the PLS, the 5-axle truck, I don't remember where the nav guy said we should consider the turning point to be, but it was like somewhere in that back set of axles. I just don't remember. But yeah, it's where, I mean, you can imagine if you look at the truck and you're sitting in it, and you look at the world rotating around you, where is it rotating around? Well, you would think that the front of the vehicle is kind of translating across the across the world as the vehicle turns, translating sideways. Whereas the thought is that the rear wheels are not translating sideways, but rather the vehicle is experiencing rotation about that point.
This is the exact same problem that my team is struggling with, right? The difference between a world frame and a vehicle frame. They have two differential wheels in the front and then a swerve that can steer in the back, right? So we've defined that the vehicle's center of turn is always just like any differential, right? If you want to have zero stress on the drivetrain, in coordinating what these three wheels are doing, then you need to consider the center of the common axle of the differential pair to be the center of the robot. But this swerve can be at a different distance relative to that, right? And it can also turn either way. And at the same time, they've got, when they're thinking about navigation, like David was saying, the point of rotation of a particular turn could be inside the robot, or it could be outside the robot. In our particular case, and they're just, the drivers are struggling with when to think about it in one way versus another way, and how to integrate the different levels of control. To what I'm advocating is that they always consider the calculator that they built to calculate the vectors of the wheels as the lowest level, which is always in vehicle frame. That's the lowest level solution, and they should be calling that from higher level navigation goals to get an instantaneous set of vectors to control the wheels. But that's not what they ended up doing at the competition. They were doing it purely from the navigation frame and sort of trying to calculate, like Ackerman steering, what all of the different wheels would be doing relative to that navigation frame. And again, that wasn't making sense at all.
So springboarding off of that thought, I just want to bring up that it was a learning for me that this group, the motion commands sent down to the drive-by-wire controller were velocity, which was considered to be the forward velocity of the vehicle, and curvature. And curvature is 1 over the radius of the point about which the vehicle as a whole turns, and that point that David showed in his drawing. And so the advantage of that is, of using curvature versus using radius, is that when you're traveling straight, curvature, which is a lot of the time, you can pick some, large number, like maybe 6,000, that's like straight enough. But the sharpest that the vehicle can turn, an Ackerman vehicle anyway, is some distance like maybe 10 meters for these trucks, which is actually the minimum radius that it can turn. So you don't end up with that singularity versus if you use radius and you want to drive straight, you could end up infinity, or if you want,
But like you said, any suitably large number can sort of substitute.
Yeah. I'm not 100% sure why they chose that, but they always used curvature rather than radius.
That's something to think about.
We'll have to think about that.
Yeah. Thank you, sir.
So Paul, when you were doing the shuttle trucks for the truck trailers back and forth from the loading dock to the storage pad, that must have been fun to do the reverse on the trucks, because your turn radius is much different there.
I imagine it was fun for the guy who did the motion planner. That was like deep math, and I was not involved in any of that.
I really enjoyed the presentation. It was good. Thank you.
Yep, yep.
Is it up already?
That's good.
There won't, the presentation will not be put up on the web or on YouTube. However,
Oh, no.
No. However, if you're interested, you can contact Paul and he can make it available to you.
Okay, that'd be great.
Yeah.
I'll email you.
Otherwise, it will be up on YouTube, but it won't be public.
1995 plus shipping and handling.
Is there sensitive information in there?
Well, you know, potentially company proprietary, that's a
Right.
sort of a gray line as to what companies consider they own versus what's considered to be sort of standard robotic knowledge. And I'm not sure how exactly to draw that line, so I just don't want videos turning up and causing problems for my former management and myself.
Hey Murray, you got anything?
Just example of
Murray? I think he's probably draining
think
this. He might be draining his basement again.
I think he's off paying his tax.
How about you, Rod?
I just
There he
came
is.
back.
There he is.
Oh, I'm sorry, I was gone for a moment. What's up?
I just said, do you have anything you want to share?
No, I could throw photos of my flooded basement. That's it.
Okay. Hey, Rod, you got anything you want to add?
Your indoor swimming pool?
If you don't mind swimming in the mud, yeah.
Yeah.
I had an 1894 Cole Eclipse banjo go underwater. It's a 127-year-old banjo just got flooded. And it's drying out now.
Hmm.
Yeah, and I've maybe have a plumber coming on Friday. He's number 7. He might come on Friday.
The banjo will be fine.
It's got a little green on it now.
I bet it's not the first time.
Probably not. Gone through a lot, I'm sure.
Rod, you got anything you want to share?
Nope, not for this week.
Okay, cool. How about you, David? Anything?
You're on mute.
Am I mute? No.
How about now? Did you guys see? I think Pat posted a link to a two-wheel balancing robot. Pat, did you do that? Somebody did.
Yeah, I posted that earlier this week, I believe, or last week.
Yeah. And okay, as you guys know, I have built and been very into balancing robots. And part of the geometry that I've always adhered to is that it's basically like us. We're pretty stable laterally, left and right, because we have a wide base. And we really have to do most of our balancing fore and aft, and that's actually how we walk. But I've always wondered about what would be the right way to give a two-wheel balancing robot the ability to manage its weight side to side. And I had envisioned, a moving weight or that sort of thing. But this link that Pat posted, I want to build one of these. What they basically have is that the two wheels are on sort of short legs, and so it can lengthen and shorten those legs and use that force. I think I can play the video here.
Boston Dynamics does that with their knee joint.
Yeah, exactly. You guys see the picture here?
Ah, yeah, that
Yes.
Okay, so important to remember now that the fore and aft is done by the wheel motors, and that you have to be into the foo of balancing robots, but the joints themselves are handled by like servo motors. And see if we get a. Is that playing?
Yes.
So you see what I mean? He can lean side to side by lengthening and shortening those two legs individually. Looks like he ought to be able to go up the steps better than that. Anyway, I think that is a really slick solution to that kind of problem. And, you know, this is kind of like a halfway, or I'd say 3/4 step toward bipedal walk, which has to solve all the same kind of problems. Pretty neat gadget, but it doesn't make me want to buy one. It makes me want to build one.
I think it's a step up from bipedal walking.
Great, Kareem. Say yes. I totally agree. Okay, that's all I got.
Boston Dynamics has a robot that does that. James Bruton showed one as well. It'd be interesting to do one that's on a linear slide also.
It's a slick solution of the side-to-side balance problem.
And it helps deal with you know, the fast turns as well.
Yeah. They're not
you can lean into them. Yeah.
Exactly. So anyway, very cool. Thanks, Pat.
Speaking of things that Pat sent out, what about the that auction thing? Is that a dead concept?
I'll take one.
Well, what would you pay for it is the question, right?
Well, let's see. Somebody's got to go out there and get it. So
No, you can have it.
I got as far as checking the so basically the way the auction site works is you can pre-bid and it'll tell you if you have the highest pre-bid or not. And so I took it all the way up to $300 as a pre-bid amount, and somebody's already pre-bid that much, and it's probably quite a bit higher. That plus the shipping is going to be, I think I got a quote for about $270, $280, something like that. So you add those together, and so the question is, how high would you want to go?
My memory is that when those were new, they were on the order of $15,000 to $20,000.
Yeah, they're not worth that anymore. That's for sure. The company's defunct, and we have no idea, you know, what's working in there. You know, I don't know how robust those sonar sensors are, but what are they worth? I think.
Or if somebody removed the drive shaft, the drivetrain.
Yeah, there's no telling what's actually worth.
What are you bidding on?
Okay, I withdraw my bid.
Yeah, I did. If you look at the pictures, though, they don't. The wheels don't look like they have much wear on them, but the chassis look pretty scuffed up.
They do look like they've had some wear and tear.
Yeah, so
maybe they were used for some kind of outdoor project.
Yeah.
Okay, so I'm totally out of the loop. What are you bidding on?
Oh, you need to. Pat put something on the. Pat put something on the list from an auction in Las Vegas, and on the auction site it said $25. That's starting bid, but that's like Kareem has said, it's way above that. But when you
6 of those old robots.
Yeah, 6 of these robots with 12 ultrasonics like Dave uses, and 2 Pitman motors in these 4 pneumatic tires that look really well, and it's all packaged together. You probably, you know,
It's got to have motors, and it looked like it had a timing belt drive.
Yeah.
Also, looking at the pictures in close-up, those ultrasonic sensors typically require a driver board to it. sensor. It looks like they have a single custom board that runs maybe 6 or 8 of them.
Six of them, yeah.
So that's kind of cool.
Hmm.
I
So
think they actually have 8 ultrasonics.
might be 8. Yeah,
So it's 16 altogether.
I think that's right.
yeah. So let me put it this way: if one of those ended under my Christmas tree, I'd be really, really happy.
Yeah.
But I'm not gonna, buy
Maybe
6
just
for
let
6.
you know,
They're I guess if you said $600, that's only 100 a piece. That
100 apiece. So
yeah,
at
that's
least. We don't
yeah.
know what it goes up
Yeah.
to, but the problem is every time I go up, it'll tell me if it's high enough or not. But I have to commit to buying it if it is, right? So I wasn't going to go beyond 300
Yeah.
for that lot, not knowing what anybody else
Yeah.
might want.
Yeah, and I also pursued, shipping. You got a number of 275 because I don't think they ever got back with me. Yeah. How did you
I
get?
got an online quote.
Yeah, how did you do that? Because I tried and tried and I just couldn't get it to work. How did you?
I went to an external shipping company, but it gives you pallet dimensions and the weight,
Yeah.
and that's typically what you need to calculate that kind of freight.
Okay. Yeah.
It was just an estimate, not a true quote. But they called me right back. They definitely wanted the business.
Yeah.
But that was just speculative. I wanted to get a ballpark for how much shipping would be.
Yeah.
My guess is that I have no idea what it's going to go for because there's like 100 people watching it, well over, and I don't know what they have in the platform.
Yeah.
I sure don't want to spend $600 on 6 robots.
No.
That I'm unlikely to use, and I don't really even have the time to part them out.
Yeah, I agree.
But there's some people in the group that might be a real good starting.
Oh, yeah.
No, there's no doubt about it, and I mean that's a robust. They were basic. I think this is like military surplus. So.
This sounds like something that some research group bought and did a project with, and it's actually been stuffed back in a closet for the last 15 years.
Yeah.
And they just started. A new guy took over, and he's cleaning out all the old crap.
Yeah.
Mm-hmm. Yeah, probably.
I mean, I'm not trying to encourage anybody, but those tires alone would be worth $100. I mean, those four tires. You go try to buy a pneumatic aluminum rim tire like the ones that they show. They're incredibly expensive.
Are they actually aluminum rim?
That's short. Yeah, no. If you go look at them when you go, the body looks like it's could go either way. It could be steel. Well, I guess I linked the original company's description of the robot in that communication.
Didn't have a whole lot of detail.
Yeah, but it might say whether it's steel or aluminum. So.
Oh, and don't discount that if it's actually got a working drivetrain, with motors and belts and pulleys and bearings and everything. That's worth a lot.
Oh yeah, yeah. But like I say, I would, in my own case, I know I'm a novice in that type of shipping. I just wouldn't have any idea how to get them something like that. Yeah, go down. Hey, Kareem, go down and show the pictures. You might as well tease everybody. Yeah.
Well, see, I remember lusting after these when they were new, but it would be sort of like going out and buying that mini bike that you always wanted when you were 10 years old.
Yeah. Yeah, I don't,
But this looks like exactly like the kind of robot that all need.
Yeah.
Serial port down at 910.
Yeah, there's 8 on 8 of the ultrasonics in the store.
And what do you suppose is supposed to go in there?
Three LED, three 7.2 LED lead acid batteries. That's what that's for.
You don't think it's for cold drinks?
Nope. Nope. Now they specify that in that sheet that I attached.
When I seen the size of those robots, it just triggered a reminder that the city of Toronto is going to be banning sidewalk robots.
Really?
Yep.
Wow.
You know, they might be still now that I'm looking at that. Correct.
So no delivery robots there.
I think that they're trying to avoid the congestion with the people on the sidewalks. It could get quite busy in downtown Toronto.
Maybe not.
So they don't trust the robot.
Do you?
Not in the least.
Elon Musk has already wiped out several people with it.
No, after Paul's talk, I think they're terrified.
Oh, those were really, really neat when I saw them.
So you really think they've been sitting for 15 years?
I think they're that old.
Yeah,
What is it? Is this the Pioneer 3?
Yep.
Let me see what they say about Pioneer.
Yeah, and I
Some of them have these thinner wheels.
Yeah, I see that.
different wheels.
Pile of robots.
Mhm.
I found a listing on eBay, $2,800 for one.
Whew.
On eBay?
Yes.
Wow.
So there you go. Somebody should just put a bid in on like 1 minute before it ends for $2,000 and sell them all on eBay for $2,000 a piece.
Yeah.
Let's see, I found the manual, Pioneer 3 operations manual. Ooh, they've got one that's got a gripper on the front.
Yeah, there's a lot of options. But these look like the bare chassis.
Yeah. It looks like all of the other stuff was stripped off of them.
But Kareem, you're right. We've reached a point in time where we can have piles of old robots.
Yeah, exactly. I did find it interesting. I went to the auction site and I just searched robots, and so we're still early in it because only 4 lots came up. This was in it. This was one of the lots, and the others were more of the standard industrial manufacturing robot arm type things. But you know, someday there's going to be like just piles of robots on auction sites.
Okay, it says here that these appeared commercially in 1995.
The motors don't look very big for the size of the robots, though. I think they'd have like a wheelchair-sized motor.
Maybe it doesn't work very well.
Can only go up a 1% grade.
Where was that? So there was a link to, or you said eBay, it was $2,500 or something like that?
Yeah, but you know, because it's on eBay doesn't mean he's actually selling them. You know.
Right.
But still, I think that's a tenth of what they cost new.
So yeah, you just put in your bid here. So if I were to do 50, I have to click on agree to buy and then confirm bid, and then it tells me I've been outbid. So you can because they said the site is scheduled, the actual auction for this item was scheduled for 3 minutes because it's all automatic, right? And it only gets extended if somebody outbids the pre-bids live. That's the only time it gets extended, and even then it doesn't get extended if it wasn't enough. Yeah, you have to outbid all of the other pre-bids. Yeah.
So we need some high-speed trading here.
That's exactly what it is. That's the only way to win this thing. Yeah. So the opens at 25 is just BS, and you have to put $5 increments in the bid. So I'm just going to go crazy here and do 400. I'm sure it's well above that already. Yep. We now know it's at least $400. The good news is shipping shouldn't go up any higher.
I never do good at actions. I always think this stuff is sold for a lot less, and it's like, nope, I'm out.
Yeah, I'm not here for speculation on resale value.
Ray, I have the same problem. I find there's almost always somebody at an auction that's willing to pay more than I am.
Yeah, maybe we're just cheap. I don't know.
Somebody told me that in Australia, the auctions work backwards from the way they do here. You had to sell a boat. You set a price you want for the boat, and then you call out, does anybody want this boat for that price? If nobody wants it, if everybody stays quiet, then they drop the price. And they keep doing that, and the first person that speaks up gets the bid. It's great for the bidders if you can hold your tongue, but kind of get screwed if you're the guy selling the boat.
Well, Paul may know about this, but when I first moved to New Zealand, there's kind of a thing that guys do in their sheds. Maybe not so much anymore, but they carve these wooden kiwis out of a particular wood called totra. And this is a shed thing, but they kind of became also tourist things. So this one was actually made by a guy theoretically named Wiramu Fukahere, who's theoretically Maori, but I found out with some research he's actually a white guy pretending to be Maori. But when I first moved to New Zealand, I bought these things, and I started collecting them. So this one's actually Victorian era, and I started getting into this, and they were purchased on the sort of New Zealand eBay, which is called Trade Me, and the bidding for these gets pretty crazy. That last few minutes when the bidding goes up, like this one cost me about $180. But right now it's worth $1,000 probably, because people stopped selling these online. But I won't show you, but I've got about 40 of them.
Oh my God.
This is probably the nicest one. I've got one that's got a clock built into it, which is about this big. And yeah, but I remember, I don't do it anymore. This is the first few years I moved here. But I remember that bidding process where you'd get up against somebody who was just determined. Unlike these Wiramu Fukahere ones, I mean, my God, this little one could go for a couple $100 if you're not careful. I let other people have those if they got beyond, but bidding is nuts online. I won't do it anymore. As David said, there's always some fanatic out there who's willing to pay more than you are.
So is that wood, is it spelled K-O-H-E-K-O-H-E?
It's Totara.
Tokara.
Totra. My floors are made out of it as well. It's a native wood.
Huh.
It can also be made out of Rimu, but most of them are made of Totra. This souvenir of New Zealand carved from a single block of New Zealand. Oh, this is kauri, sorry. Of New Zealand kauri represents New Zealand's unique rare bird, the kiwi. It has no wings or tail. A work of art by the old carver, Wiramu Fukahere, who is bullshitting. Apparently that's not his real name.
Mm-hmm.
But these were sold in Auckland in the 1950s and 60s as tourist things.
Yeah. Anyway, when I went to New Zealand, I got this ruler of all the woods of New Zealand.
Yes.
And,
Paul, you don't remember this, eh?
No, never saw that.
Ah, it goes back like well over 100 years. This, like I said, is about 1880s.
But a somewhat cynical comment from the Kiwi would be that the Americans were quite smart when they selected their national bird. They were going to select a turkey, but then they turned around and realized that the eagle was much more regal and grand. Kiwis not quite so smart. They selected a flightless bird that runs around in the dark at night and eats grubs out of dead logs.
Yeah.
Well, the Canadians got a beaver, right?
At one time they tried to make the armadillo the Texas state animal, but it fell from favor. And basically the truth is that the only thing Texans do with armadillos is hit them on the highway.
Yeah.
If not for them being hit on the highway, we wouldn't really know they existed.
Yeah, the only natural enemy they have are cars.
Yeah.
And all that magnificent armor that worked so well for millions of years suddenly becomes useless against an automobile.
Yeah, it
Yeah.
can be
When I
extremely-
came to Texas, they used to call them Texas road bumps.
Yeah, that's the only thing left after the coyotes get them. It's just in my backyard.
Well, we drive over Australian marsupials here.
Well, these are marsupials. They are marsupials. They're very
Are they
strange. They have a shell on the back and they have a furry stomach. And they have their young live and put them in a pouch.
So maybe your marsupials are just meant to be roadkill.
Evolution's roadkill.
Yeah. And we have Australian possums here eating our forests and killing our birds. So when you hit a possum, it's yay.
Yeah.
We've got a whole plethora of stuff to hit on the highways here.
Moose
Marmots,
being one of them.
chipmunks, skunks, raccoons, wolves, dogs,
You
cats.
don't want to hit a moose.
You don't want to hit a skunk.
A moose will hit you.
Yeah.
You hit a moose in a vehicle, most of the time you don't survive.
Yeah.
Yeah,
Unless
they're
it's
kind
a
of designed
transport
to be
truck.
up to windscreen level, right?
Yeah.
Yeah, their
Well, what
legs
do
are
you
coming
do? You
along.
snap its legs off. They're 4 feet tall. You
Mhm.
snap its legs off, and the body rides the hood into the windshield.
Yeah. They can be well over 1,000 pounds, right?
Oh, bigger
Oh,
than that.
yeah. Yeah.
I hate it when that.
Mm.
Well, I want to know what Chris has been doing.
Ah,
Sitting over there quietly.
Yeah, that's because I haven't been doing much. I don't know, just too much day job kind of work, and yeah, and I have to clean up my. I really have to clean up my workspace here. That's why again it's a bit messy in the background. I'm starting to run out of surfaces to put stuff on, and it's just time for some cleanup and reorganization. I'm actually on vacation, so in theory I should have time now, because as of this week I'm on vacation for the rest of the year. But somehow I have the feeling I'm still not going to find a ton of time. I have visitors coming in and for Christmas from Germany, and so I don't know. Somehow I just haven't been finding the time lately.
Hmm.
Well, I'm glad it's not just me.
Yeah.
So, Chris, one question that came up at the talk on Saturday was about gazebo, and I was just curious. You did a great ROS demo showing navigation, and I was just curious whether you had constructed a gazebo model of your robot.
Well, I do have a very basic URDF file that describes the footprint and the kind of dimensions of the robot. It's fairly basic. I've taken something I found that was a close enough match and I've modified it. But again, it's just got only the basics in there. Yeah, it's useful to a point. It does help.
Well, URDF is what you want to show it on RViz, but you need more than that to put it into Gazebo and make it useful in a simulation, in a closed loop, in a software in the loop simulation. You need to plug in the LiDAR and the differential drive modules at a minimum.
Yeah, I haven't been using Gazebo much for a number of reasons. I just somehow haven't found it very user friendly. I don't know when it was. It's all a blur. I've done a presentation on, one of the Saturday presentations on simulation. My favorite simulator sort of so far has been PaleoSim, or used to be called something else. I forget now. And more recently, I've been trying to get up to speed on VBots, because it does appear to be more efficient, a little faster, and it also has less. It has more clear licensing terms. The Compiler Sim, in one place it says if you're a hobbyist, you're fine. In other places they don't explicitly mention the hobbyist is fine, so it is a little less clear. But so VBots is what I'm trying to get up to speed on. It's still not as user-friendly as Compiler Sim. So what I showed, so I don't currently have something that's working really well in simulation. Again, in the past with Compiler Sim, I have used it extensively, not with RAWs, but just for troubleshooting my logic in closed loop, in a fully closed loop kind of setting. Again, that was completely outside of RAWs. It was just using simulation so I can, so I can save some time, right, in diagnosing and testing my software. So again, more recently, VBots is what I'm trying to look at. Again, Gazebo is also, I've always found it to be really resource hungry, and until just recently, I haven't had all my computers been a bit old. It's only as of literally just a couple of weeks ago that I have a laptop that's powerful enough to not get bogged down, completely, when you run something like Gazebo or Simulator, or even like Google Meet was enough to bog down my laptop. So with that, I'm trying to sort of get back a little bit into having a proper simulation setup. Like I said, with VBots, they have a few things, sort of samples ready to go to show off how they work with RAWs. So instead of using Gazebo, which is kind of the default simulator in RAWs land,
What was
VBots has
the
a
other
couple
one?
samples.
Karina. What was the name of the other simulator that you said you've used?
Compiler Sim. Let me type it into the
How do you
chat
spell
here.
that?
I gotta double check that I'm correct, but they have changed names at one stage. I'm pretty sure that's the one. Yeah, no, okay. Compiler Robotics is the name of the company now, and Compiler Sim, like I spelled it there, is the name of the simulator. And I found it, of all the ones I've looked at, I found it the most user friendly. It's got a lot more user interface driven, GUI driven configuration going on. You don't have to sort of write stuff in text files that are cryptic in some language that you have to first learn. So I found that one really the most user friendly. But again, VBots seems to be very promising as well, especially from a performance point of view. It's just I'm still struggling a little bit with VBots because it's just a little more cryptic how you set it up. It's just a little less drag and drop. And again, Compiler Sim, you click on something, you get a dialog box, with a ton of options on it, but it's just the learning curve is just not as steep there with Compiler Sim. So but yeah, they both have the capability to work very closely in a RAWs type environment. And I did start to play with VBots, and it's turnkey samples that it provides. I think they simulate the Turtlebot 3 burger style robot, right, which is one of the standard RAWs sample platforms. So there's sort of starting points there. And I've been starting to play in particular with the with the lidar scanner, because again that's one of the things I want to simulate, so I can work with different algorithms and try different things efficiently, right, without having to chase behind my robot. And so that's what I've been doing. So I've been doing a little bit, nothing to show off really, but trying to explore how does that lidar work? How closely can I make it behave in simulation like the real lidar behaves? And unfortunately, that's where it gets a little tricky. Again, the real lidars, as I've said a couple times before, in the real world, you have a moving and turning robot, and the lidar spins. You get all kinds of sort of distortion type artifacts that most of the simulators they just don't give you that, right? They can give you a noisy signal. Right? They can do that, right? You don't just get a precise, reading at a given angle. Oh no, okay, they give you a little bit of noise, but they don't give you that distortion that you get when your robot's moving and the lidar is turning at the same time, and so you get a much better, you get a much cleaner lidar scan in simulation than you get in the real world. And you can, in both Copelia Sim and VBots, if you wanted to really get a very realistic lidar scan, you'd have to set the simulation time step to something so small, right, that basically at every time step, the lidar moves by just exactly, one increment. And then you sort of get a simulation where I guess you are it is capturing all the sort of real world artifacts of the motion. But again, at that point, your simulation runs so slow that it's no longer practical. So you have to find a trade-off somewhere, and just accept the fact that in the simulated world, your lidar data is always going to look a little better, than in the real world. It's unfortunate that, but still, it's valuable to have a simulation set up, as I again said before. I just, currently in RAW is not fully set up. That's what I'm working on, but as everybody knows, with the learning curve there in RAW, there's just a lot of things you gotta put together correctly for that to work, for that to all work. So.
Thanks for the update and the pointers to those simulators. I see that Copelia used to be VREP.
Exactly.
I've heard of it. I never looked into VREP at all, but I know now that it has a substantial history.
Mm-hmm.
Yeah, they both have. They've given all three: Gazebo, VBots, VREP, or Copelia Sim. They've all been around for a long time, and they're all good. And you just gotta, I guess, pick one and invest your time in it, and that's what you learn and get up to speed on. And so I'm just kind of, like I said, a bit in between Copelia Sim and VBots, and trying to get up to speed on VBots, because it does seem substantially faster than Copelia Sim, and so it's that has its benefits.
Chris, are you saying VBot? Could you put in the name in the chat, please?
If you guys are interested, just since we're on the subject of simulation, if you guys are interested, I'll show you something interesting that I ran into in Gazebo that is just absolutely ate my lunch.
Hey Chris, I think David and I have the same question. What laptop did you get?
Oh, okay. So yeah, Black Friday or whatever sales week, I did get a Lenovo Legion 5. Well, Lenovo Legion 5, 17-inch screen, which is bigger than I wanted, but hey, that's the one that was on sale, and given that my eyes are not getting any better, it's actually not such a bad thing to have a bigger screen. It was on sale for $700, and I put in an extra hard drive and extra memory, so with tax and everything, it comes to $800, which is, I guess, still in the budget gaming laptop territory. But the main thing is you gotta have, for some of the things like running a simulation fast and not getting bogged down, you gotta have a discrete GPU. That's really all that matters, right? You just have a standard laptop is gonna have the GPU built into your micro, and they're good, but that's the limiting factor. So So, you know, the moment you have a discrete GPU, you're kind of in gaming laptop territory. Not that I'm gonna use it predominantly for gaming, but that's kind of the keyword you're looking for. You know, budget gaming laptop,
Yeah.
and you know, you get something with a discrete GPU, and that, you know, helps a lot with, you know, even with Google Meet. I mean, anything that's heavy on the visuals, but simulations especially, you know, they tell you a lot of times right away, you know, your computer's not up to snuff. You know, you really need to get something better. So they all work. All the simulators work on mediocre hardware. You know, if you just, your user experience isn't gonna be great if your simulation, you know, runs less in real time. You know, it's kind of, yeah, it's a user experience and kind of productivity kind of bummer.
So is it Intel based, like an i7 or i9?
Mine has a, what do I got? To be honest, I forgot. I have an AMD, I forgot which one, a Ryzen 5600 something rather. I can look up the specs and put it in the chat. Again, it's what was on sale, and you know, you get what you pay for. So it's not top of the line, but it's all I needed really. It's all I needed. That's the point. I needed something with a GPU, and it's not the latest and greatest GPU either, right? It's entry level discrete GPU. Can play some games. I have been playing some games, so maybe that's why I haven't been building robots, because I have been finding myself getting a little distracted. Ever since I have a gaming laptop, well, let's see what this thing can do.
Yeah, you should at least explore it once.
Well, it looks here, I just poked around a little bit. You got a pretty good price. The best I saw here was something like $950.
Yeah, they come in different configurations, but you're right. I mean, it was $200 off, so that configuration usually runs around 900, and I got it for 700. You know, they skimped on the RAM a little bit, so I had to put in an extra 8 gigs of RAM. I had an old SSD sitting around. It comes obviously with SSD, a 256 SSD, which isn't very big. So I took an old SSD that I had, you know, I took it from the old computer, put it into this one. It had been room enough for another SSD. So again, with upgrades and tags, figure 800, and that's, you know, I think it's decent for that price.
Well, that's good information. Thank
you. Go for like 3,000 or something.
Well, yeah, you can spend 3 times as much, 4 times as much. You know, you're gonna get 3 times as much performance, you know. But I don't need 3 times as much performance. You know, this is good.
It probably wouldn't improve my gaming skills either. You know?
Yeah, exactly. And I play the simple games. I had, you know, I played Quake 3 Arena because that's what I played 20 years ago, you know, so I don't have to learn that game. I know how to play it. So
Yeah, I'm fortunately looking at upgrading a 7-year-old desktop, and I'm easily into the $2,800 to $3,000 range to develop a laptop. But,
yeah, it seems like the prices have gone up a lot.
well, they're expensive here anyway, so yeah, that's like a Core i9 10900 20 core machine.
wow. Yeah, I was torn in between, should I get a desktop or a laptop? You know, you get a little bit more performance for the same amount of money, maybe if you go for a desktop. But then, from what I've seen, is they tend to be louder. I mean, they've got a lot of fans going on in the desktops, and that was one thing I was concerned about. You know, and I've looked at the reviews. I didn't want something that, if I'm just browsing the web, I don't want to hear a fan, period. I mean, that thing should not be making noise if all I'm doing is browsing the web, okay? And so the one I have right now, if I put it into, you know, the right kind of power mode, it doesn't make a beat. You know, it's dead silent, and that's how it should be, right? I mean, because that'll drive me nuts if I'm just sitting there reading a document or reading something, and I can hear the fan noise. I mean, that'll just annoy the heck out of me.
Well, I made the mistake of speccing out some machines and workstations for our office, and so I watched my home compile of the same code. The home compile was almost 2 minutes, and it went down to 15 seconds. So I come home, and it just seems I've been spoiled. So now I want that same machine. I want the 15-second compile time now.
Well, the other thing, we just got a bunch of new equipment. This is rack mount stuff at work to replace some basically 10-year-old equipment. And what I'm struck with is not only are they much quieter, they just don't take nearly as much power. That's a huge difference.
Yeah, that i9 on my desk at work that does the 15-second compile time is a huge box, but fans aren't hardly ever running on it. I mean, I can't stress that machine out. 15-second compile time, by the time it's even heated up, it's finished. It's kind of hard to imagine unless you're running it as a server that you could stress a machine like that out.
That's why I'm determined that you need to upgrade every 20 years, whether you think you need it or not.
20 years now, you can't. I mean, I'm driving my equipment pretty hard for a pretty long time, but I can't go 20 years.
Saturday I showed the 25-year-old machine.
Man, mine's 7, but I'm a software developer, so I'm always spoiled, right?
So I've got something that I think is interesting related to simulators, and specifically physics simulators, that I think you guys would be interested in.
I diverted your discussion there.
No, that's fine. I'm going to share my screen, and hopefully you guys are seeing the simulation that I showed on Saturday. Is that coming through?
Mm-hmm.
Yes.
Yep. Okay, so here's the interesting thing. So this is Gazebo, and so this is sort of about how physics simulators work and what can be their weaknesses. So if we turn it transparent and we turn it to wireframe and we view contacts, actually we view collisions. So collisions, collisions. So collisions in Gazebo are the objects that can touch each other and act upon each other. So the wheels can act upon the ground. And now the interesting thing that I want to point out is when you turn on contacts, you will get these little blue balls here, and what those are they're the physics simulator iterates every 1,000 times a second and computes the forces between interacting objects or collisions in Gazebo speak, and computes therefore what the next incremental movement to what force and therefore the movement of the object should be. Well, there's only 2 points on this wheel, so Gazebo and apparently other simulators like this actually don't compute a full series of contacts at all. They just pick some points on objects that are in contact with one another, and compute the behavior of the objects from that. And so you can see you've got 2 on each of the rear wheels and 1 on the spherical caster. What I was finding, and it just absolutely killed me because about 1/3 of my simulations of the trucks would fail, was these balls would jump around, and you're like from the side to the middle to the further way across and backwards and forwards sometimes. And as a result, they would impart some kind of motion to the wheels sometimes. So about maybe a tenth to a third of my simulation runs, the model would go sliding across the ground because these contacts were jittery. Anyway, someone explained to me what was going on there, and I just thought it was really interesting and thought you guys would be interested in the concept of just a few points that are evaluated for interaction between objects and how that can fail. That's all I had.
Paul, are those points actually, the wheels actually imputing torque to the ground?
Yes, they are. And so if I stop the robot moving a little bit, you can see that it's flickering. The front one is flickering as like reevaluates where the turning moment is, and the back ones are stable in this run. I don't know if they'll always be stable, but it was a major problem for me with the truck that these would not be stable.
Well, one thing you have to keep in mind, and you probably know this, but most of these simulators, they do only rigid body dynamics. And I barely know what those words mean. So but I know that it means you can't simulate regular soft tires of any kind that you would typically use, right? So that right away, a lot of stuff goes out the window, right? Because it's just rigid body dynamics, and that limits, I guess, the degree of realism you're gonna get right there.
Yeah. Anyway, that spoke to me about the optimizations that they do. They're trying to compute. I mean, Gazebo is, and really the underlying physics engine like ODE is trying to compute the interactions between these bodies and their inertias 1,000 times a second if it's to keep up with real time, and so they do some algorithmic shortcuts to select only certain points between interacting surfaces for evaluation. I just thought that was really interesting, a point about how they build simulators and what its effects on the simulation can be.
Did you solve the problem of them moving around?
Yeah, I pressed the stop button, but I can start it again.
Okay.
Well, did you mean, did you somehow change programming to get them to stop jittering around, or did you ever find a solution for that?
I never found a solution.
Oh, okay.
Now,
one
thing, and you mentioned ODE, in Copelia Sim, you get to choose what underlying physics engine you want to use. So ODE.
Right, I saw that. I was looking at it while you were describing it, and you get a choice of ODE, Bullet, and two others.
Yeah.
And Gazebo offers a choice of ODE, Bullet, and one other. And I never tried messing with different physics engines, but people did tell me that ODE was maybe not as good as Bullet, but I never dug into how to change out the physics engine.
Yeah, I just remember from when at a time when I was using Copelia Sim extensively for competitions for the robot. I don't, I do know that again in one of them, and maybe it was ODE was doing weird stuff, and just like you kind of described, it was just kind of a little jitterish for no apparent reason, and switching to the other physics engine just kind of made it go away. I'm sure you can make it work with ODE too. I can't believe that it's a bad sort of physics engine. But the other thing I've learned when I was using it extensively, you gotta make sure you input all your masses properly of your your robot, and some of the engines tend to struggle a little bit when the mass is too small. You know, you almost have to sort of artificially inflate the mass of your robot, I found, just so that whatever calculations it's doing, right, is becomes more stable, apparently, is what I read, and it
Yeah.
seems to be true.
Yeah.
So that's just something to consider. You know, masses seem to be very important. You can't, you know, they just didn't seem to like, you know, very low masses.
Yeah.
Hey,
Masses
Paul-
and inertia both.
Paul, you know, in the simulation you showed us, the little blue ball that was underneath the roller, or the single point, kept disappearing. Is that because it's at that point is actually losing contact with the surface?
Good question. I don't know what that means.
If you
I was
push
gonna
it,
say that it could very well be that, you know.
you know, if you push it, you know, or otherwise you were pushing it. If you make the robot go in the other direction, does it stay, or does it disappear?
Did you have rough terrain in your model?
No.
Completely flat?
Yeah. I can try that real quick.
Now, what you're explaining might actually just explain something I ran into that I could never figure out what was going on, right? So I was doing a two-wheel differential drive robot in Kibitzing, and you know, and I used the information from the simulator, you know, to do odometry, right? The wheels are moving, and you know, I was using all that information to sort of essentially convert that into encoder clicks, if you may. Okay, and so I thought, oh, so to reflect a real-world robot, you know, I'm probably going to have to add some noise to this, right? Because I get a little bit of wheel slip going on or whatever, right? But then I found that even in simulation, I expected my encoders to basically be just dead-on accurate, right, in simulation. Because why shouldn't they? Well, they were not, and I could never figure out why. But again, what you're just pointing out, right? I mean, if that contact point between the wheel and the ground, you know, keeps kind of moving around a little bit, then that might, you know, what I think is going on, you know, and how the robot is moving in simulation may not line up, and so that might explain why my simulated encoder ticks were actually not dead on accurate, even though I thought that's what I should get.
Yeah, is that a ball, Paul? Is that a ball, or is it just a contact point?
The blue thing is.
No, I mean the ball. Yeah, is that fixed or is it rotating?
It's just a marker. It's not anything represented in the physical world.
No, the gray ball, the big ball.
The big ball.
The big ball is the big thing is a caster.
So it's actually rotating. It's not being dragged across the surface.
It's probably not rotating. If you don't have a joint in there, if you don't have explicitly put a rotation joint in there, then it won't be rotating. It's just going to be dragged along, and you know, some of these things you can configure the friction. That's what I've done in my setups. You know, I put something there, and I give it, you know, 0 friction or very low friction, and then, you know, that's fine.
Yeah, I was going to ask you, did you input like?
Yeah, if it's not rotating and it has a friction value, then I could see it jumping the surface every once in a while.
That's a really good point.
It can only rotate if you put a joint in there, right? And this thing is attached to the joint, then it can rotate.
Maybe you had a chattering caster.
Yeah, exactly right.
This is the URDF.
Well, Paul, I have an observation about your points of contact jumping back and forth on the main wheels. Those, since those wheels, at least in the model there, are pieces of a cylinder, and if you have real wheels real robot wheels in the real world that are shaped like that, they do the same thing, which is a problem. So I don't know if y'all can see this, but this is a nice robot wheel, but you see it's fairly cylindrical. And so depending on which way you're turning, the point around which it rotates actually does change. So these are not very good for odometry. The ones that I use tend to look like this. They have an oval profile, so that there really is just a single point of contact. So maybe that your model jumping around is a model of what real wheels do, because you have a cylindrical wheel there rather than a whatever you call that.
Yeah, that's a real good point. And to your point, Chris, I think you're correct. And Doug, I think you debugged my problem for me. The caster joint is of height fixed, meaning that it wouldn't rotate. So thank you, guys.
No problem.
Between the 16 of us, there's a brain.
We just can't buy lots of 6 robots, that's all.
Yeah, that's real interesting. And it's a real interesting observation you made too, David. But I think the observation that I was trying to convey, though, was I was modeling tires that were like real truck width, 12 inches or so wide, but there were only typically 2 contact points that the simulator was evaluating, and they moved, like jittered about across the wheel. Yes, I understand your point that real wheels would jitter and skid as the wheel turned, but in the simulation world, I think my problem was something different.
Well, you could try the wheels that only have one contact point, like
V profile,
and see what happens, and that might make all the difference.
Yeah.
Well,
I'm not working on a truck
make
anymore.
it
Hey,
within the wheel.
so you just tell them when they get into the parking lot, they just have to pump up their tires until they're nice and round.
Yeah, there you go.
So Paul, what's your goal for the simulation ultimately?
That's my goal for what?
For the simulation, what are you using it for?
So that particular one was something I did for the job interview for the robot, for the yard trucks, but it was based off of one for my robot lawnmower, and so I have a different one that I haven't made work yet, but it is dimensionally reasonably accurate to the robot lawnmower, and I want to use it as a development vehicle for the robot lawnmower and be able to run the robot software against either the simulation or the real robot.
Yeah, I guess I didn't think about that. The wider the wheel is, the more skidding you're going to get as that wheel turns. I mean, it's, the inside radius and the outside radius, they're going to be different. And so I imagine there's quite a bit of, tread wearing, because
You can test it real fast. Just change your cylinder width on those wheels, something really big, and then down to 0, and see what the difference is.
Yeah.
Well, I can verify that does happen in real world robots with wide tires. It's not dependable.
It has to.
It's not dependable what point they'll locate it. Although this may be totally off topic, but a friend of mine who was into race cars and especially off-road racing and NASCAR was talking to me about the physics of that one time, which was not at all as I had expected. And he said you have to think at those high speeds that they're going, that it's kind of like driving on ice. That effectively you don't have real good contact with the road. And so when you turn, yes, the wheels are changing their angle, the steering wheels are changing their angle, but that really what's going on at high speeds is that the suspension is shifting the weight of the vehicle from being equal on all four wheels or whatever, however it's set up, to loading the outside front tire. So the whole vehicle rotates around that outside front tire. If that tire slides forward, we call that understeer. If the back end breaks free, we call that oversteer. But basically, he said that at high speeds like that, it's really which tire has the most weight on it, which is when you turn the steering wheel, you apply weight to that outside tire, and that's what the car rotates. And you know, in those NASCARs, if somebody just touches them, they go spinning out. You know, they're really unstable. And he said driving on ice is a good way to think about it. So in that case, the suspension really has a deep part of the control of the car, not just which direction the wheels are pointed in the turn. Just one more piece to add to your simulation.
Yeah, I think Volvo did a thing where, you know, to control vehicles in snow, they would actually break the four wheels independently. And, you know, they were able to control skidding much better that way. So I kind of wonder which wheel they were, maybe the opposite of the wheel that had the most weight on it. Maybe that was the one that was being braked or something. Yeah, that's interesting. Well, I am going to skinny wheels on the back of the lawn mowing robot, because not because of any other reason, but I need to stick a brake on there and I need some space on the axle. The axle's only so long, so it's like a 4-inch wheel instead of an 8-inch wide wheel. So.
That's going to be a peculiar looking riding mower, right?
It will, yeah. It'll be odd for sure, but that's okay. I live out in the country. Almost no one will see it.
It almost sounds like the beginnings of a new Stephen King novel.
Could be. And to Ed's comment, I actually did get those tires at a reasonable price at Surplus Center. It's the shipping that always kills me. It's like the shipping sometimes is as much as the tire is.
Well, I'm going to have to give surpluscenter.com a little more looking at, because, you know, like I guess everybody here, I always dream of the robot that's about the size of Scott's. You know what I mean? It's big, you know, bigger. Never, you know, I never can justify working on a platform like that when I've got so many other platforms that aren't working really well. So, you know, I got to get them working better first. But after I get my RC-based car working, I want to actually make a robot frame with some ideas that I have. You know, but it's going to be big, not monstrous, but big. You know, big. Maybe I can ride on it. So, you know, we'll see how it goes. That would be cool. Yeah.
Yeah, I'm kind of doing the same thing. I got.
Well, your mowers are pretty big too already, so you're well on that path.
These are like 10-inch diameter wheels. And they have a pretty aggressive tread pattern on them. They're like 2 inches wide.
Yeah.
And it's all plastic.
Yeah.
But they were, I think, either $3 or $4 from Surplus Center.
Oh, that is cheap.
Yeah. So.
Even if you paid equal amount for shipping, that's reasonable.
Yeah. So I only need 4 of them, but I got 8 of them just in case, you know, they wear out a lot quicker than I think they. But I kind of like the, you know, the crosshatch tread.
Mm-hmm.
Well, guys, I think I need to bail.
Yeah, I think it's about time, guys. I'll tell you what, if nobody else has anything, I'm going to cut the recording. We can stay around a little bit if you want to, but I'm going to stop recording in 5, 4, 3, 2, 1.